Hello everyone. So today I'm gonna work on this procedural scaffolding system. So here you can see this is driven by a spline, and I can change the spline, and you can see how it is how it changes the scaffolding. So here you can see even though I'm using PCG, it can do a line trace and detect detect the flow underneath, and it can put as much as required scaffolds underneath it to support and get to this level. So yeah, and if I adjust this line, you can see it get adjusted according to what is required. So sampling a spline and placing some static meshes is not a big deal, but the additional thing that we are going to learn here is how to get the spline points and how to determine how long we have to go below the spline point to reach the solid ground, and from the solid ground we are going to place these scaffolding meshes. So that's the important thing that we are going to do here. So we will create a custom PCG node that can do those line tracing and determine the ground and add additional points to the point grid in order to spawn additional meshes. Right, so before we get started, let me remind you that you can download the project files of this project and all other thousands of projects I had done from my Patreon page. Once you become a member, you can download everything without any limit, so feel free to check it out. I'll leave the link in description below. And feel free to check out the previous 2 episodes of this PCG series as well. This is the 3rd episode. Alright, now to get started, here let me create first a blueprint PCG scaffolding. Right. Now let me open it and let's add a spline component into this. I'll set the spline point type to linear. For ease, you can make it curved as well, but for this it's enough to be linear. Okay, now compile, and also I'll add a PCG component this, and here we don't have a PCG graph yet for this purpose, so I'll create one PCG graph. I'll call it PCG scaffolding, and I'll assign it like this. Okay, now if I place this scaffolding, set bit higher, in a bit higher position. Okay. Right, that should be enough to get started. So I can move it up. Yeah. Alright, now let me open my scaffolding PCG graph. So here I can get spline data and then spawn static mesh spawner. Oh wait, before that we need to sample the spline using spline sampler and out this point. So if I go here, nothing happens yet. And here you can keep the default settings because we are using this within this blueprint itself. So by default via actor filter itself, and when we get spline data, we will get a reference to this spline. Right. Now if I press T here, you see I can see this line segments. So that means we actually get spline data into our PCG graph. So let me remove debug by pressing T again, and here under mesh entries I already have a scaffold mesh, so I'll assign it here. So this is the mesh. It's a simple mesh, nothing special about it. So it spawns like this, which is not the way I want it to spawn. So let's go back here. Under spline sampler, I'll use the mode to distance, and distance increment I'll make it 200 because that's the length of this scaffold. And now you see it's like this. So if it is a horizontal surface, it would be fine, but this is not the way I want it to be. Alright, now to do a line trace and determine the points below this spline that we need to spawn these scaffold meshes, we need to create a custom node, custom PCG node. So just like we did yesterday, if you don't know, if you can check out examples of custom nodes here. If I just select anything like this, and you can go to its position. So here you see a number of examples. So here, if I open this one, you see what it does is distance to density. Well, I don't really know. So anyway, the important thing is if you go to class defaults, you can see under advanced, sorry, not advanced, under input and output, you can see custom input pens. So here you can define inputs and outputs as well. So let me go back to my folder. I don't need this. And let's duplicate this sphere grid node that we created yesterday. I'll name it trace below. So here, this is the only function that we have overridden, execute with context. And here you can see we have this output pins, and we set points as the output, and we give the output like this. So basically I'm gonna copy this part, but we don't really need any of these things. Now let me remove that. I'll keep this because I need to use it for the output. I don't need the radius or cell size or the owner location. Alright, now trace below. Now if I go to PCG scaffolding, by the way, I know you don't have this node, so this is all I have. I have execute with context, and take a look at this. Construct PCG points, set points. This is all we have right now. Okay, now if I go to my graph and type trace below, oh, it's track below, sorry, it should be trace. Okay, now here you see, right now it only has an output, point data output, but here if I go to class defaults, and inputs and output, add an input. By the way, this is the parent class is PCG blueprint element, in case you didn't notice. So here, label, points, same points, allow type, point. Okay. Now if I go to the graph, here you see, now we have this in points, so we can give the points as an input. Okay, so now how do we get these input points and how to do a trace from those points? So to understand that, if I go to this distance to density, the node that already exists here, you can see it get like this. Custom labels to array, get inputs by pin label. So this should give the inputs. We can access inputs using the pin label. Pin label means the label that we have given here. So let's do the same. In here, my input name is this, in points, and get inputs by pin label. I'll use in points. Now we have PCG tagged data structure array. I'll run a for each loop on this, and then here break PCG tagged data, cast PCG special data, and 2-point data with context. You have the context here as an input here. Okay, let's follow the same method. Context here. Okay. Break PCG tagged data and pass to special data, PCG special data, and as PCG special data, 2-point data with context, and we can access context from this, which I happen to have a reroute node here already. So I'll pass it. Now the next thing is, here we get PCG point data object reference, and it's using this point loop node, which is not something implemented in in Blueprint. It's in C++. If you double click, it will open in Visual Studio, but here you have this under flow control. This Blueprint overrides point loop body, which is essentially gives us a way to access each points in the given point data and do stuff with that, basically. So this is a multi-threaded loop. So let's not worry about that now. Let's see. So let's do the same. Point loop. Text this. Okay. Now let's override this point loop. Point loop body. Okay. At the point loop, we are already in point loop body. So here, now we can access each point using this in point. So this endpoint will have the current point that we have sampled current points that we have sampled with the spline sampler. Now let me get that. Reg PCG point, and here we have the transform. Let me break the transform also. Oh, we can split this here. Now, as I said, we can do a line trace by channel. This would be the starting point and the end point. This, I'll split this, and let's put 5000 here. But let me promote this to a variable. I'll call it trace distance. Right, by default we have 5000 there, and I'll not do anything here. Let me just add a debug type and compile. Now see, we have a debug type. Okay, so, and it's going upward, so that means trace distance, since we are tracing down, multiply this with -1. Now it's tracing down, and it already hits here. So I think it's colliding with these meshes itself. So we need to, even though we have ignore self, since this is in a PCG, maybe it's not identifying this these spawned instances of meshes. So from context we can get component, and from this we can get owner actor. Then here let's make an array and put this owner, send actor to ignore. Right, now it goes below and it can now properly do the trace. Okay, great. So what's next? Okay, now it's just plain blueprints. So here, if we get a hit, set a branch, then I'll write this hit result, and I only need to access this location. And then I'll subtract this point location, this hit location from the point location. The reason to do that is we need to determine a number of points that we need to spawn our spawn scaffolds underneath, not just. So for that, now once we have the, when I subtract this, and if I divide, no, yeah, only the set value is important to me because we need to determine how many points below. So if I divide this by, I know that this scaffold, this height is 170 units. I know that because I made it. So maybe we should promote this as a variable. To variable, let's call it trace step. Let's make this public so they can be edited here. here. So this one 170, so we can edit if needed. Okay, now let's run a for loop to add point. I'll start with -1 so that we will start one below. Oh no, let's just start with 0. You will understand it. Right. Now for each of these points, if I multiply this by this trace step, and then I'll add to this location. Now this is going to be a point that we need to spawn a scaffold. So I'll add it to an array, but here we were using this PCG points. This is a local variable. Can I move it like this? No, doesn't seem possible. Okay, so I'll just out points PCG point and array. Okay, now here we can get out points and add points to that. So make PCG point. Okay. Now the location and scale is 111. I don't want to change that right now, but we might need the maybe just the set component of the rotation. So here we have the endpoint. Right, rotator, connect the EO. Okay, now it is added to this out points array. We still need to return this. Okay, all right. Still nothing much happens, only the tracing. Now to return this, let's go here, execute with context, and connect the rest of the code. And instead of this output points, I'll use out points. And this is not needed now. Okay, rest I will keep the same. And now here, break this and connect. Now you see we have scaffolds underneath this spline all the way to the ground. Okay, so yeah, and you see they are floating above the ground. So maybe if I start this with, that's what I was thinking before, -1, we will have always one below like this. Okay, so yeah, this is all I want to do today. Here, if you adjust, you can see now it's procedurally adjusting the scaffolds. That should be enough for today. It's our procedural scaffold system. So thanks for watching. As always, updated project files will be available here for download in the Patreon page, and let me know if you have any questions in the comments below, and don't forget to like and subscribe. See you in another tutorial. Goodbye.